All right, in this video, we want to show that a particular number is not a limit of a given function. So let us take as our function the function f of x, defined as follows. If x is greater than 3, then f of x is going to be equal to number 2. If x is smaller than 3, then f of x is going to be also the number 2. Now, if x is actually equal to 3, actually I wrote 1 here, but I really meant 3. Let me actually change that. No, I'm sorry. If x equals 3, yeah, I want to put that 3 there. If x is equal to 3, okay, then we're going to let f of x equal to 1 be equal to 1. So obviously the domain of the function f of x is the whole real line, and this is a graph of this function. Now, so notice that for all values of x except the number 3 here, the function is constant at 2. When x equals 3, the value of the function falls to 1, and for all other values of x, it is actually 2. So this is the graph of the function f of x. Now, the problem that they have asked us to solve is to show that this function has a property that the limit of this function does not equal to 1 as x approaches 3. They want us to show this in a rather formal fashion. So in order to do this, I am going to have to state the definition of what a limit is. So the definition here is written in red. The definition says that the limit of a function f of x is equal to a value b as x approaches a if given any epsilon, any, look at the word any here, it's important, greater than 0, where epsilon is some arbitrary number, usually very, very small. There exists a corresponding delta. Now this delta depends on this epsilon, greater or equal to 0, actually we just wrote greater than 0, such that the distance between x and a is smaller than delta, such that, sorry, if, let me put the if here, if the distance, if, let me write this down, such that if, okay, such that if, okay, that goes in there, such that if the distance between x and a is smaller than delta, then that immediately implies that the distance between f of x and b is smaller than epsilon. Now, of course, here notice that b, okay, is the limit. So that's what it means for a function to have limit b as x approaches a. Okay, so what we want to show is that this function here does not have that property, does not satisfy the definition of having limit as x approaches 3 equal to 1. Okay, so this is actually not, it is the case that it does not equal to 1. So what we are going to do then is we're going to choose an epsilon. We have an arbitrary choice of epsilons, but we're going to choose an epsilon which is actually a smaller distance than the distance from here to any point. So we're going to be choosing an epsilon of smaller distance than the distance from here to here. So an epsilon that we'll do is epsilon equals to 1/2. Alright, so we're going to let me actually do this in black. So I'm going to let I'm going to let epsilon equal to a half, right? We're going to let epsilon equals to a half. Then if the limit of f of x, the limit of if the limit of f of x as x approaches 3 is equal to 1, it would have to be the case, right? It would have to be so that there exists corresponding delta greater than 0 such that the distance between x and 3 smaller than delta, right? So such that if the distance, between x and 3 is smaller than delta, then the distance between f of x and the number 1 must be smaller than epsilon. Now, of course, we chose epsilon to be a half here. So this is saying that in order for this limit to be actually the limit of f of x as x approaches 3 to be 1, then it would have to be the case that there exists a corresponding delta greater than 0. That's what the definition says, such that if the distance between x and 3 is smaller than delta, then the distance between f of x and 1 is smaller than epsilon. But obviously this is not going to be possible, because look at the distance between the value y equals 1 and the value y equals 2. It is always greater than 1, greater or equal to, it is always 1. So you are not going to find a delta having the property that when the distance between 3 and, let's say, some value x here is smaller than delta, the distance between f of x and 1 is going to be smaller than epsilon. So obviously this function does not have the property that the limit as x approaches 3 equals 1, and we have shown what we showed out, what we set out to show. So this is not clearly, no such delta exists. Therefore, we know right away that the limit as x approaches 3 of f of x does not equal to the number 1. Exactly what we wanted to show. Thank you for listening.